Hey, all my Chem peeps, it's Mrs. Guido. We are looking at transition metals today. So this page is looking at rules for naming compounds. We're going to be specifically looking at the ionic compounds again, but now we're in this middle square. So right here it says ionic compounds that contain a transition metal. Remember, the transition metals are the metals that are in the D block. So it's going to be these metals specifically are going to be the ones that we're looking at. Why do they have different rules? They have different rules because these metals have different types of charges. So remember when we get to the D block, we had like the S block, the D block, the P block, and then the S block is down there. The orbital is a weird shape. So it's like a weird electron cloud. And so sometimes an element could have like a +4 charge, and sometimes it could have a 2+ charge. So it's not so simple like the first two blocks. This block, we know that this one, they all are going to be 1+. And that second column, these guys are all going to be 2+. But when we get to our transition metals, things get a little bit funky. So we need to make sure that we are identifying which type of, let's say we're talking about iron, which type of iron are we talking about? So let's get back to those rules. So for the first part, we are going to write the name of the metal. So just like before, if we had sodium, for example, Na, you would just say sodium. But then the next part is a little bit different. It says include a Roman numeral to denote the charge of the metal. So in this example, it's saying, okay, well, the specific iron we're talking about has a 3+ charge. So the Roman numeral that we're going to use is going to be Roman numeral 3. The Roman numeral 3 is identifying that specific transition metal's charge. Some exceptions to our transition metals are going to be these three right here, and actually I'm going to have you write a few down on your periodic table. So silver, you don't have to have a Roman numeral. Cadmium don't have to have a Roman numeral, and zinc you don't have to have a Roman numeral because they only have one set charge. You guys are going to get this periodic table in school, but we are not there. And this little periodic table helps outline the different charges. So if we like zoomed in here, you can see that titanium has 3 different types of variations. So it could have a 4+, a 3+, or a 2+. Same with iron. Iron has 2 different types. It could be 3+ or 2+. Same with nickel. So we have lots of different variations of these. So the ones that are crossed out, this little box right here, these guys are going to be the ones that don't have variations. A lot of people forget that tin and lead are transition metals. They do fall underneath that staircase area, and these guys do have Roman numerals. So tin and lead will have Roman numerals. So those ones we will use quite often, and that's why I'm specifically pointing those ones out for you. Okay, sweet. So let's get to the notes, and then we'll do some practice problems, and then you guys will have a worksheet on that. Cool, so here we are. So transition metals are ions with multiple cations. Transition metals usually form a 2+, a 3+, or a 4+ charge. So that example, we have copper. Copper actually can form just a 1+ or a 2+. So depending on the type of copper, are we talking about the 1+ copper? Or are we talking about the 2+ copper? So if we're talking about the 1+ copper, then we would say copper, and you would do Roman numeral 1 for that first one, for right here. Where if we were doing the other one, copper 2+, then we would, I'm going to do that in a different color. We would write that as copper and then Roman numeral 2. Again, the Roman numeral is telling us that charge for that element. And transition metals can have different sets of charges. Okay, next slide. So on your periodic table, if you have it in front of you right now, you can go ahead and mark these down. So zinc has a 2+ charge, silver has a 1+ charge, cadmium has a 2+ charge, and then you have your tin can have a 2+ or a 4+, and lead could have a 2+ or a 4+ as well. So naming metals with multiple ions. So this is what I've already talked about. So why don't you go ahead and try to fill out this practice area right here. What would the Fe3+, how would we turn that into the written out name? So go ahead and pause the video and write that out. Okay, so Fe is iron, so it should be iron. And then since it is a 3+, we would do Roman numeral 1, 2, 3. So that would be that one. The next one, Pb is lead, and it's 4+. So when we're looking at our Roman numerals, it's important that you know that 1 is like that, 2, 3, 4, and then this is 5. And then 6, 7. We're not really going to get this high up there, but you just add on to there. Cool. So you do need to learn your Roman numerals. People get 4 and 6 mixed up because they look similar, like they're the opposite of each other. Just think like you're starting off with like 1, 1, 2, 1, 2, 3, then you do like another line, and then you do your 5, and then your V, and then V and +1. That makes sense. Okay, so this would have a 4 next to it, Roman numeral 4. Again, the Roman numeral is telling us that lead has a charge of 4+. When we're given the Roman numeral, like in the next example, mercury, remember, is Hg, is the symbol, and so this would have a 3+ charge. All metals are cations, and cations have positive charges. Then we have chromium. Chromium is Cr, and this chromium has a 2+ charge. Hopefully that makes sense. So we're going to use the crisscross method in our second little section to figure out what the formula will be for each of these compounds. So I'll do the first one with you, and then pause it and see if you can do 2, 3, and 4 on your own. So the Roman numeral 3 is telling me that iron has a 3+ charge. We know that oxygen, I'm going to get rid of this. We know that oxygen is in this column, right? And it is 2 away from being a noble gas, so it's going to form a 2- charge. So 2-. So then we do the crisscross. So I need, for 2 irons, I'm going to need 3 oxygens. So then you go ahead and write that in. So Fe is the symbol for iron, 2, oxygen, 3. And that's the correct formula for iron 3 oxide. So go ahead and pause it. Try to do 2, 3, and 4 on your own, and then we will continue on with the notes. Alrighty, so we have chromium. Remember that since the line is in front of the V, that means it's 4. So chromium has a charge of 4+. Fluorine has a charge of 1-. You can go look at the periodic. Oops, that's not it. Fluorine's right here, so it's a 1- charge. So we do the crisscross. So for every chromium, I need 1 chromium for every 4 fluorines. 4 fluorines. And that is a really ugly chromium. So let me make that better. Way better. Okay, the next one we have nickel nitride. So nickel 2 nitride. So that means that our nickel has a charge of 2+. Again, I'm getting that number from my Roman numeral. The nickel is a transition metal, so we don't know what its charge is unless the Roman numeral is given to us. So that's why we need the Roman numeral. Nitrogen has a 3- charge. So when we write it in, we have Ni. We need 3 of those. Again, the crisscross. And then nitrogen will need 2 of those. We have a charge of 5 plus, a charge of 2 minus. Those won't cancel each other down, so it is what it is. So we have V2O5. And that's how we go from the name to the formula. But we also need to know how to go from the formula to the name. So I have that on another page. I want you guys to pause it again and see if you can figure this out on your own. So give yourself like a minute or two to try to figure it out. And then we'll go through it again together. Okay, so we have copper. Oops, hold up. We have copper, and we don't know copper's charge. Well, we do actually. We can uncrisscross. So notice copper doesn't have anything next to it, so that means there's a 1 there. So if we uncrisscross the charges, this 2 means that there's 2 coppers, or it has a charge of 2. And we know that chlorine has a charge of 1. So that goes with the chlorine, right? If we uncrisscross, copper has a 2 plus, so that means I need to throw it in the Roman numeral 2. And then chlor, and then again, remember we have to have that "ide" ending. So not chlorine, but it's chloride, just like in the binary, naming binary compounds. Okay, the next one, we have nickel. And we have oxygen. We know that nickel, well, we know that it says that there's only 1 nickel and that there's only 1 oxygen. When there's an oxygen, you should always think, oh, oxygen has a 2 minus charge. Well, if oxygen has a 2 minus charge and it's a 1-to-1 ratio, then that means that nickel had to have a 2 plus charge for those to be reduced down to a 1-to-1. So we have nickel, and we're going to show it as 2. Oops, hold up. 2 oxide. Again, that "ide" ending. Nickel 2 oxide. All right, so we have an iron and bromine. So we uncrisscross. So that 2 goes over here, so it's a 2 plus. And then bromine we know has a 1 minus. How do I know that again? If we go to our periodic table, bromine is right here, and it's in that column 1 away from the noble gases. So it'll gain 1 electron, becoming negatively charged. So this is going to be iron 2 bromide. That's supposed to be an R. There you go. Okay, we have our next one. Our next one is manganese. And when we uncrisscross, I need 3 of those and 2 of those. So that means manganese had a charge of 3, and we have manganese 3 oxide. Okay, now we have our zinc. And we uncrisscross. So I know fluorine has a 1 minus charge, so the 1's there. And then that's going to be a 2 plus charge. So zinc 2 fluoride. Oops, I forgot the O. I'll throw it in there for you. Whoop. Wow, that's so ugly. Hold on. Oh my gosh. Can I undo it? Oh, thank goodness. Here we go. For some reason for this video, I decided not to put my computer screen flat down, and my handwriting's paying for it. All right, sweet. So zinc 2 fluoride. Hopefully this all makes sense. These are your examples for your worksheet. You do have a worksheet. Let's see here. It's posted in Canvas for you. So this is you should have already done this ionic binary metal review. That's due tonight at 9 p.m. And this is the video that you should have clicked on and you're watching currently right now. Here are some extra videos. Again, if you hate me and hate my videos, these ones are somebody else teaching the exact same thing. So it might be beneficial to get it from a second point of view if it's just not clicking what I'm throwing out there for you. And then your worksheet is going to be right here for you. So you can go ahead and click on that and download that worksheet. Answer those questions, resubmit it for points, and it should look like, if it loads, should look like this. So the top part of this worksheet, so 1 and, oh, just kidding, the whole thing is transition. Perfect, never mind. I was thinking some of it was binary. So for 1 and 2, you're just going from, I don't know why it like separated it together, but it should just be one long list, but it's fine. For 1 and 2, you're just going from the formula to the name, and then 3 and 4, you're going from the name to the formula. So get those done and then submit those into Canvas. Go ahead and try to sketch these out as well if you can. Use if you have what are these things called? The little pen things that you can like draw on your computer with. If you have that, then you can give that a shot. If you don't, then you can just like verbally explain to me like what it looks like, and that will be fine for your points on that. Cool. And so then you'll submit that. You guys are going to have a quiz Friday, so tomorrow, on transition metals and binary metals. So it'll be comboed together. And you will have a practice worksheet before that, and I'll have a video up before that, and then you'll take the quiz, just kind of like how we do it in class. So if you have any questions, send me an email or send me a remind text, and I will try to get those answered ASAP. I love you guys, and I will talk to you later. Toodaloo.